the destination, because every time you send a packet, the destination could have moved from one place to another place. So in real life, what we do is, if one of our friends is like this, he's graduating from college, going to job and so on, and moving from one job to another job, there is one address where we know this is his permanent address. Okay? So usually it's parents. And we will first, always when we want to contact this friend, we will contact his permanent address and we will learn where that person is currently situated. And we will take something called the care of address, what we know C/O, when you write on the angular. So we get the care of address and then we directly communicate with it. Right? So this is the approach that is followed in reality, and the protocol, network protocol is also based on this. So when they design, so standard TCP IP is only for static nodes. When you connect to the internet, all of these, what TCP IP that you use is for static nodes. When you start moving, you need something called mobile IP. Right? Because the routing will change, and this is what the specification is, mobile IP. Now, different other approaches would be, we change all the routing tables whenever a person moves, but we saw that this is not scalable, because in the entire world, you have to change all the routing tables, right? So it's a big effort. That is not scalable as you decide on the number of nodes that are moving. So let the system handle it, not the routing table, the end system. At the end point, when I say end point, is the destination and source and the correspondent. Right? So only the end system will do something so that we can have the mobility. With that approach, there are still two ways you can do it. One is indirect routing and one is direct routing. In the indirect routing, this is the basic approach, where you first get the new address, but your communication from the correspondent to the destination is always through the permanent address. Right? So what you see is a triangle, and we'll see that there is a triangle of routing that forms, and it's inefficient because always you have to contact the permanent address, care of address, then the destination. Another thing is the direct routing, where you learn where that mobile node is situated right now, and you don't talk to the permanent address. You directly contact to the care of address. And this is more efficient, but it requires more intelligence. So, in the animation, there is home network, visited network. So whenever the mobile node visits network, it first contact, it has to always get a router that it connects to and register with this router, so that this router knows that there is a new or a guest coming into his network. He will assign the proper IP to this node and then contact its home network. Right? And if you say this is a mobile is resident in my network, is it permitted to access the net and so on. So once this router says, okay, this node is a legitimate node, so this might send a username and a password. It will authenticate it, and then we tell this router, okay, go ahead and take care of this node for me. And the home network also learns about this new location. So with this, even this router is aware that this node, this mobile node has moved from this network to that network. So it also registers in its own database. So both the foreign agent and home agent, this is the home agent and this is the foreign agent, they are aware of the mobile node at the end of this day. Then when it comes to the actual sending of data, this is the correspondent who wants to send the data. So what it will do is, it always has its IP address as the home network, right? Because this guy knows that the IP address of this is situated here, so the routing will actually come here. And then the home agent knows that the mobile node is no more here, it is in a visited network, so it will intercept that packet, and instead of sending it in the home network, it will send all the way to the visited network. So this packet will be delivered to the destination, and now the destination doesn't have to go through this entire route, right? Because the packet contains the source address of the correspondent. Right? So that address is always coming all the way up to here. So when the destination wants to reply back, it can directly send the packet to the correspondent. This is how mobile routing is done. This is how it is done even in the GSM network. So we'll see in the standard telephone network how is it done. And this, it forms a triangle, so it's also called as a triangle routing. points about the indirect routing. So mobile node is using two addresses. One is in its home network where it is already situated, which is called the permanent address. So correspondent will always use this permanent address, and then there is a care of address in the visiting network. And this is what the correspondent will learn dynamically. So now another thing is if the mobile node moves from one network to a second network, what would happen? Can you think what would happen now? So this was one movement, right? It moved from home to visiting network. Now visiting network 1 to visiting network 2.
Care of address.
Right, so care of address has to change. Right? So if you want to design the protocol, what you can do is when it moves from the second, it moves to the second visiting network, it will again contact. So first of all, let me just draw it, it's easy to understand. So this is home, this is visiting 1, and now this is visiting 2 network. Right? And this is the correspondent. Initially, your mobile node is here. This is agent here. This is agent here. And now if the mobile node moves here, there will be another agent here, a separate agent, right? So whenever it moves here, the mobile node, first of all, it has to register with that local network. If the agent does not accept this mobile node, it cannot communicate. Right? So the router first of all has to accept. So it will communicate to this node. Now this agent knows that there is a new node. So let's see, what will be the protocol now? So you have to give me all the steps sequentially. What should happen? So you are free to design. Don't worry about what is exactly in the protocol. Just
Contact the home network.
Right. So this would be this. So this guy can contact the home network.
Then route to the.
Yes. So this will. This home agent now knows that the mobile node has moved to another visiting network. So it will update its own database, and now it will communicate to this, and it will have a different care of address. Now when the correspondent talks to the permanent address, the packet will be sent here and not here. Right? So this is one way. What could be another way? Or
through V1 it can.
right. So another protocol would be. So when the mobile node moves from V1 to V2, right? So this path is already established, right? So home agent knows that this M1, or home agent right now knows that M1 is in V1, right? Next time it moves to V2, this agent, so this can be its second home network now, right? So this A and this A, V1 and V2's agent can talk to each other and establish that link, right? So now what will happen is when the packet comes, it will first come here, then it will come here, and then it will come here. So this is now what we are doing is just extending it. Right? Instead of communication between all of this, we are just extending it. So it's like daisy chain. You connect one hop to another hop and second hop and third hop, and you can continue doing this. So this is also fine, but it's just that there the packet has to jump from one agent to another agent to third agent and so on. Right? So these are two ways, and you can use either one of these. So foreign agent functions can be done by the mobile itself. It can be the function of routing. So it's not important. And since it is all indirect like this, it's also called as triangle routing. So this is what is talking about moving between networks now. Suppose the mobile user moves to another network, the case we just talked about. So it will register with the new foreign agent. That is must, regardless of which protocol you use. It has to register with the new agent. The new foreign agent can register that what you discuss or that what you came up with the home agent. Right? So it will directly communicate to the home agent, and home agent will update its care of address, and the packet now will be sent to the home agent and then directly to the new. Right? So this also is fine. So the advantage of this is mobility and changing foreign networks is transferred to the correspondent. Right? So correspondent is never aware that something like this is happening because all of his first packet are always going to the permanent network. Right? So this is how you can maintain the connection or the Skype call. If there is a Skype call between the mobile node and the correspondent, the packets will always follow like this. First they will go here. If the mobile node moves here, they will go here. Then the replies will immediately come back directly. Right? So this is what is proposed in the mobility, and you can use the same IP address and still communicate. And the advantage of this is you never update the routing tables anywhere. You see that I never talked about routing table.
In case of mobile phones, by looking at the mobile number, we can identify that this number is from India, right?
Right.
But in case that I want to contact a particular computer, so what will we use to identify that computer?
Okay. So you mean the country?
Yeah.
Anybody knows? Anybody has tried?
IP address.
IP address is something, right? So all the countries has assigned a pool of IP addresses. So you can find out the country from the IP address.
But okay, home has one IP address, V1 has another IP address, and
Right.
V2 has another IP
Another
address.
IP address.
I want to contact this particular computer, which has one IP address when he was in home. When he moved to V1,
Right.
he'll have another IP address.
Right.
Then how will I identify? I hope I'm on right track. That the new IP address which my system has got when he reached V1 is mine only when corresponding with
Right. So what happens is when the mobile node moves here, the new network, the IP address that it receives for this V1 is local. So let's take an example concrete. So let's say there is a M1 in US right now. It has its US IP address. It moves to India. It will first of all will get a local IP address. Without it, because this agent in India is not entitled or authenticated to give a US IP address. Right? So for example, you join BSNL network here. The BSNL router cannot give you US IP address. Right? So it will give you an Indian IP address. But this node, and we'll see how it is done, this mobile node tells that I have this IP address from US. And I want to receive my communication for this US IP address also. Now, the BSNL router will communicate with the corresponding US router and say, okay, one of your node is.
But how will the one in V1 identify that I am coming from H?
Right. So that is where there would be an authentication protocol. So maybe A will ask you a username and a password, and your agent's IP address, your home agent's IP address. So
some new thing will be added, some kind which can actually identify my computer or.
That's right. Right. So if you take an example of roaming, so let's say there is a US number, and that person comes to India, he can still use the same SIM card.
But
right?
in this case we have a constant number, but here we cannot use MAC.
Right, so MAC is out of question, there is no MAC, only IP.
IP changes.
IP changes, but now this M is, you can think that this has two IP addresses.
Okay.
So this is, even with the same interface, it has two IPs. Right? One, it is remembering from his home network, and one for the local network. Right? Now what will happen is these are the two IP addresses. One IP address it uses to establish this connection and gets its routing done here like this. And the second IP address, so for example, now this mobile node is interested in sending an email. So I was talking about the Skype call. So that is what you have to continuously maintain. But email you send and you stop, right? So for that you can use the second IP address. And that should be fine.
This is fine, but is it really a case that we have two IP addresses associated with my...
Yes, yes, and this can be done even on your local computer. Right, so what it is doing is, it is called tunneling. So actually, so even in Windows you can do. You can search Google and find out. So you can create a virtual IP. Right? So if I have 192.168.1 dot something here, and then you want to create a new network among your friends, which is 198.168.100 dot something, right? So you can create on the same interface, and you can create as many virtual IP addresses as one and as many virtual networks. And all of these virtual networks will be separated from each other. And this is actually being done. So if you know the faculty IP address is 192.168.1 dot something, and I think students are getting 4 and 5 or something, right? And it's using the same switches, same ports, but all of these are separated because they are virtually created. So what we call, if you take Cisco certifications and so on, right? It's called VLAN. I would recommend, I mean, those who are interested in networks can really go and read some books from Cisco and so on. This is called a VLAN, and this is a standard term, and it's a virtual LAN. So this is one virtual LAN, this is second virtual LAN, and so on. So same thing is happening here, and same thing. Do you remember anything with V in networks? Maybe this term you must have heard, right? VPN.
Virtual private network.
So anybody knows what VPN is? This is what you use for registering for ERP also, right? Sometimes you want to check grids, and we enable VPN. It's a virtual private network. So what happens in VPN? So even if you don't know the technical things, it's fine. But so this technology also gives you mobility. If I am in the campus, I can access all the websites, ERP, Moodle, everything, right? Websites and so on. If I go out of the campus, I cannot access some of the websites. For example, ERP. Right? But if I enable VPN, then I can be mobile and still access it. So can you tell me in layman terms what exactly is VPN? And then maybe I will try to explain in technical things what VPN is. You know what VPN is? Okay, so when you are in the campus, what is the thing that makes you or enables you to access ERP?
We are on this internet.
We are on this internet. So you are something which is like this, like 4 dot something, 5 dot something, or 1 dot something. Then you can access. It's within the same subnet. Okay. Now if you go home, you cannot access it because
We are not on this internet. We are on internet by.
right. So you are now on the internet, and this subnet is different. Institute subnet is different from your home subnet. Home subnet is again will have something like this, but it's local here. And now, if you type ERP dot something, it will first go to the DNS of your home network. It will try to map it. It will not find an entry because we don't put this entry in the DNS for erp.iiitd.edu.in. Right? It's local only. Right? So your computer will say, okay, address not found. Okay. So that way you cannot connect it. Now if you enable VPN or we enable VPN here, what's happening is in the router of our home, so home is like this now. Home is the institute, right? So we tell that, so we give you an IP address, right? A URL. It's 190 something dot something, right? So basically it's the IP address of our router. And this IP address is accessible over the internet. It has a global, unique static IP address. So now what happens is you connect to this router. When you connect to the router of the institute, it will ask you for a username password. It gives you username password. If it's all correct, it will authenticate you and assign you a local IP address, like this. Right? So your machine now has 2 IP addresses. One is, let's say, your BSNL internet, that IP address, and a local IP address for VPN. This is one more example of having 2 IP addresses with the same interface. And now when you type ERP something, the router will forward it accordingly and you can access. Right? So this is called tunneling. VPN is also tunneling. Corporates use it for a lot of other purposes. For example, all the communication within Reliance will be separated from all the communication from Tata because they are competitors. They don't want their single packet to go from Reliance to Tata or vice versa. So they will create these VPNs. Right? So all the people spread across the globe who are working for Tata will use this VPN and communicate among each other, even using a Reliance connection. And Reliance will not know anything what they are talking about, right? And vice versa. And this is all used by the big corporates for the same purpose. Right? So their purpose is different. Their purpose is to separate traffic between two competitors. Our purpose is different. We want you to get a local access. And this is what is being done here also. It's a tunneling. Because this mobile node is now having two IP addresses at the end, and both are being used.
Even Moodle is accessible outside through VPN.
So Moodle has a static global IP address, so without VPN also you can access it. Right? But we don't want ERP because of the security attacks. Right? And because very sensitive data, and we don't want any security attacks to get that data. We don't want grades being modified outside on the internet. Right? So that's
But without knowing the username password, nobody can access ERP.
So there are two ways, there are two things. One is the username and password for the ERP system, and then is username and password for this router, which is different. Right? So this will ask you for a cyber realm password. Right? And ERP has a different username password. Right? So first you will authenticate it to see whether you are within the institute or not, and then you can get access to the VPN, and through that you access ERP. Right? So this is how all the things come together. Mobility and VPN and tunneling and so on. Okay, so coming back to this, so this is all transparent for the user, which is the best part of the solution. So user doesn't have to know. Now the other thing is the direct routing. So you see, indirect routing has a disadvantage that you always have to go through the home network again and again, right? So in this case, what we're doing is correspondent request to number 2. So number 1 is still the same. You will contact the permanent address. In the number 2, your correspondent request receives foreign address of the mobile. Right? You basically get the foreign address. Right? So in this case, you don't need to actively use two IP addresses at the mobile node. Right? So mobile node is just having one IP address, and one IP address is just for the dormant purpose. So once the correspondent learns the second IP address, it will directly communicate using the second IP address. Now this is a little bit challenging because the correspondent node always have to keep on changing this IP address. Now if you move from V1 to V2 to V3 to V4, the connection would break. Right? So before that, it has to get a new IP address and so on. But now the challenge is, how do we get the new IP address? So let me set the problem again. So this is home network, this is correspondent. Mobile node moves from here to here. Correspondent will first talk to the permanent address, get the new IP address, and now send the packet here and will receive the response. Okay, now this is all fine. Now this node, mobile node, moved from this network to another network. What would happen? Let's see, the correspondence is still the same. It is not moving, but we want to maintain the connection. How would you set up the next steps of the protocol?
This visit network router will forward the address of the new router, like where the node has visited.
Right. So this is now acting like a home network. Right? So this has become a home network, new home network. Okay? Now when the node moves from, let me draw here one more, to V2, and this is V1. Right? So mobile node is here. What's happening is, there is an agent here. Right? So when M moves here, it registers here, and then this is its home network. Because for correspondent, now this has become a permanent address, a new permanent address for the mobile node. Right? So packet will come here, and then it will come via like this, and it will get back in fact this agent will respond by saying that the new IP address of the mobile node is here. So correspondent, the next IP packet will directly come. So let me say it again. When M moves from V1 to V2, the correspondent still thinks that this is now its permanent address, but this agent knows because of the registration process, that the mobile node is in the second network, V2. So it will reply saying the IP address of the mobile node is this. Okay, so this agent will reply. And now the next packet will directly come like this. Is this clear? So you're actually moving the permanent address. So permanent address is not really permanent, right? It keeps on changing. So this is the challenge, and that was the advantage of indirect routing. The permanent address is always permanent, right? And here the permanent address has kind of changed. Now this is one corresponding, C1. What happens with C2? So C1 knows that now this is the new network and this is the new IP address. It can directly communicate. C2, what will C2 do?
C2 will assign it to original home network. And then the actual site it to
this network. Right, and this network, this will come here, it will come here, and then from here. Yeah. Right? So you have to keep learning the new IP addresses in a chain-like manner. Then only C2 can communicate. So C2 will always go here, then it will, because this agent only knows about this IP address, so it will come here, this agent will say, okay, this mobile node has already moved, IP address is this one. And so C2 will now communicate here. Okay, so you have to form this chain and then it happens. So we see the complexity has little increased as compared to indirect routing. Actually, even if it was inefficient, it was simple. But this has become a little more complex and there is a chance of, so one of the agent reboots for some reason or goes down. One router goes down. Right? So for example, our router, there is no backup power supply, it switches off. The whole chain is broken now. Right? In the previous case, you can still go to the permanent network and still retrieve back. In this case, if one of the router in the chain is broke, the link is broken and you don't have the path. So, this kind of routing overcomes triangle routing problem, the inefficiency, but it is non-transparent to the correspondent. The correspondent has to be more, or it has to have intelligence. Retrieve the new IP address and talk to that IP address. And if you change the mobile network, you see the complexity still increases. You have to keep forming this chain from one visiting network to another and so on. Right, so we already talked about this, I will skip this here. When it moves from one network to another network and so on. So we saw what happens for the IP. Right, so the important part was, it's called mobile IP. If somebody asked you about mobile IP, now you all know what exactly it is. So this is on top of TCP IP. Standard TCP IP is one protocol, and then IP was modified and it is now called mobile IP. But in reality, two things never almost happened on the internet. One is, so the protocols were there, but it never happened. One is the broadcast or multicast. Not really happened. Right? And the second thing was this mobile app. So even for changing from IPv4 to IPv6, it's almost taking 10 years and still people are. So we are still using IPv4, version 4. We are not going to IPv6, right? So the reason these things are not happening in reality is because you see the protocol has to be changed on all the computers. Right? If you want to use direct routing, I have to rewrite the TCP IP in all the operating system. And it's just a huge task. And not only it has to happen globally. Right? So even if one router moves to the next version of the protocol and the second router is still sitting with the old version, again it becomes a communication problem. Everybody has to move. And now we are in a stage where even the phones are running IP protocol, TCP IP protocol. So I have to reflash all the phones, computers, laptops, routers at the same time. But that's just a huge task. So it's not happening. So broadcast and mobile IP is...
But we can say, like introduce IPv6 in some router and even like have a backward compatibility for IPv4.
Right.
And we target computer network that from tunneling like one IPv6 and then some IPv4 and IPv6, so we can tunneling we can communicate.
Right. So what happens is all of these are patch-up-like solutions and they create inefficiency. Right? So because the router has to run two protocols at the same time and keep on. So router is a very fast device. It has to operate at the speed of light. almost at the speed of light. And if you ask him to have multiple protocols and do tunneling, so tunneling is still additional work. Right? That will slow down the performance. Right? So that's why people say, okay, I mean, I don't care, I will just stick with the old protocol and operate at the highest speed.
And also there are limited number of tunneling that you can possibly can
Right, so that is also there because the bits are number of bits and so on are always limited.
But someday or the other we have to shift.
We have to, right? So always, so Google typically, if you see after every 6 months or so, will always say, okay, ours is an IPv6 day to day, and we'll use this and that. And so they are doing it, they are pushing it, but it will take time. And the same thing happened with mobile IP. Right? So protocol was there, but nobody was really using it. But now with 4G, there is a big need. So 3G is not completely mobile, but what people say is 4G will give you all these protocols in reality. So now we'll see how this handoffs, so it's called handoff. In the GSM network, when you move from one subnet to another subnet, it's called handoff. You see how it is done in cellular networks. There are lots of similarities. So by the way, this is RFC 3220. It's a protocol well designed, it's already there. It has home agent, foreign agent, just like you described. Registration, care of address, encapsulation is that also means tunneling. It's the same thing. So there is a packet within the packet. There will be IP address outside, IP address inside. And it uses indirect routing for datagram. So it's not using direct, it's indirect. You have agent discovery and the registration with home agent. So the protocol is in place. So let me skip this because it's again doing the same protocol explanation but with just the IP addresses. So you can go through this animation. But anybody knows what ICMP is? Right, it's used by router. It's a management protocol, and what is it used for? Any standard example that you know?
Ping.
Right? So if you want to exchange messages between routers or between two nodes for mostly maintenance purpose or management purposes. So ping is also management. You just want to see whether the other router is alive or not. Right? So all of these messages will go through ICMP. Right? So even the discovery of the agent, when you join the new network and you want to discover whether there is an agent or not, you want to register and so on. So all of that thing will use ICMP packets. So it's a standard packet run at IP layer, and this is what we need. So okay, so moving on to cellular networks. So in cellular networks, we don't have a router, right? So what we have, so there is a cell phone tower, which is like an access point, and then this so this entity, MSC, is connecting it to the telephone network. So we are not assuming internet for now. Let's assume that we just have voice call. Okay? There is no data access. In that scenario, what will happen is, these are the cells, neighboring cells. Each one of these cells will have a cell phone tower, and multiple of cells will be connected to one MSC. It's a switching center. Right? So this has its own MSC and so on. And all of this will connect to the telephone network, the line network, and then you can call up a line using this now. So this is how it is done. And now the mobility is within the cell. So within the cell is very easy. You don't need to do anything, right? Because it's the same cell phone tower. When you move from one cell to another cell, it is little complex, but still the complexity is not that much because your MSC is still the same. When somebody dials your cell phone number from the landline, it will still come to the same MSC, right? And now MSC has to decide whether to send it to this or this. On the worst, it can send it on all the cell phones. And this is what is happening, right? So when somebody calls your number, it comes to the MSC and it can send it to all the cell phone towers if it doesn't know where you are currently. All the cell phone tower will know that there is a number being dialed and they will send wherever. So let's say you are here. Your phone will pick it up from this cell phone. So this is how it is done. And this is acting like a hub now. You can actively see whether you are in one cell or another cell. Challenge is one MSC to another MSC. So if you move from one cell to another cell, and now you are in a different MSC, now there is a challenge. Right? So we'll see how this is done. So every home network, for us it's Delhi network, will have a home location register, HLR. That is the database containing your permanent cell phone number that you receive from the cell phone operator, your profile information. So for example, you have 2G, 3G, GPRS and so on, roaming enable, not, which plan you have for roaming, which plan you have for the local calling. So all that information is stored in this database, it's called HLR. And information about your current location, this is very important. So the database maintains where you are currently located. So the cell phone company can actually track it. And then when you go to the visiting network, there is another database in addition to the HLR, because visiting network will also have its own HLR, and then also visitor location register, VLR, and it is the database for each of the roaming users in the network. And so if you move from here to, let's say, Bangalore, your name will be registered in the VLR in the Bangalore. Right? And this could be your home network also. So if you have another SIM card, or if you have a SIM card for Bangalore, it could be your home network. Right? But depending upon that, you have entry in HLR and VLR. So we'll see indirect routing, the same routing that we talked about in IP for mobile. So this is HLR, this is my home network. Home network mobile switching center. So this is the LSC. Right? And say if I'm moving from this network to a new network for mobile, so this is a new mobile switching center with VLR. Right? So once I come into this, it will get registered in the VLR. Now there is a call. Right? So somebody calls me, this is the correspondent, we are using the same terms. Correspondent calls me using a landline. It will always, because my home number is here, it will come here, it will end here, and then, so home MSC considers this database. HLR is a database, and it gets the roaming number of the mobile. So I talked about that there is another number assigned to me in the roaming region. So if I am in Bangalore, I have a Bangalore number also. Just like I have 2 IP addresses, now my phone has got 2 telephone numbers, but it's transparent to me. I don't know what my Bangalore number is. This HLR maintains this information. So it gets the roaming number in the visiting network, and then the switching center will use its telephone network and connect me here, and then the call will come here. Okay? So this is why, we discuss about this. So if I don't pick up the phone call, this switching center will play the voicemail, and this will probably, if I'm in Bangalore, it will be in Kannada and so on, right? So it's all regional thing. And the call ends at the cell phone there. And now whatever reply that I send can directly go. So it will come to this mobile switching center and it can directly go here. So it's now again the triangle routing, right? Even for the mobile network. So if I move from, so now we have seen the complex thing where you move from one MSC to another MSC, right? And that's where all the databases are updated. But if you are in the same mobile switching center, so you don't change your area or the region, then what's going to happen is a handoff, right? And this is what you typically also see. So route a call with the new base station. So if you are moving from here to the airport, you are changing cell phone towers and you are being handed off by tower 1 to tower 2 and 3 and 4 and so on. So how that is done? First of all, the reason for handoff is stronger signal. Right? So if you are mobile, the signal that you get from the tower is diminishing as you move away from. So it's the standard physics. Right? And then you enter the next cell phone tower, your phone will see that the connectivity is low. You will see all the signals bar coming down, down, down. And then you know that you can no longer maintain this connectivity. Even in your laptop, if you move away from the access point, you will see that. And then another reason could be balancing. So for example, even if you are stationary, you can see that your tower will change sometime. right? It's tower 1 or sometimes tower 2. And it's because there is too much load on one tower and it cannot take your connection. So it will hand you off to the second tower, nearby tower. So this is also done for the load balancing. Right? So GSM protocol doesn't mandate why to perform handoff. So protocol doesn't say why to do handoff. So it's all the way to the operator. So Vodafone has its own one policy and Airtel will have second policy. It's all, but it just mentions how it will be done. So any guesses what will be the process? And you don't want to drop the call. So that is the most important thing. If I allow you to drop the call, it's very easy. Right? But if I don't want you to drop the call, how will you do a handoff? Can you think about it? Let's think for 2 minutes and tell me, you have to tell me the steps of the protocol. There could be, so just to tell you the complexity, there could be two reasons for packet drop. Either you're here and the packet comes here, which is like you already have handed off and the packet will arrive here, but then you are still very close to this cell phone tower and you cannot receive it. Or vice versa, you move here and the packet comes here and you haven't established the new connection. So you don't want to drop the packet at any point.
So what we could do is the old base station, there's the new base station handover is going to take place,
Okay.
and allocate the resources.
Okay.
And the mobile will also make a connection to the new base station and a soft handover in which the mobile is talking
So
to.
let's see the step. The first step is important. So old BSS talks to the new BSS, right? Right? And the important step there is, as you're mentioning, you have to allocate the resources accordingly. So the new BSS has to have a right frequency, an empty frequency being unused. So for FDMA, they are available. If it is not available in the new base station, the new base station will say, I cannot take this new mobile number into me because I don't have an empty frequency to allocate. Right? And in that case, this will reject it. Okay? But if you have the resources, you have to reserve those resources. So that is also important. Still, your connection is with the old BSS, but you have already reserved resources in the next set. Okay, so let's see the next one.
So the connection between the new base station and the mobile station is made without breaking the old connection.
Okay.
And routing is done through both the connections. So this acts as a soft handover in which same traffic is exchanged between both the connections. And then the next
that could be a challenging thing. It may not be possible to simultaneously get connected to the two towers. So it's like having two masters, right? If you have two masters and the packets are coming from both the interfaces, then there will be duplicate packets coming at the phone, and then the phone may not be able to find out that these are duplicates. So you might hear an echo if you play both the sounds. And this is also typically echo means what? You hear again and again, right? And that means the packets are being duplicated and your phone cannot recognize this. So it will play both the sounds for you. And that is what echo is typically. Right? So that may not be a good idea because the phone may not be able to detect it. Right? So establishing both the connection at the same time is little challenge. The resources are reserved, you can't enter that same. Right? So you make the arrangements there, now you have to move them. How would you move without dropping the packets? So you are free to design the solution, but yeah, just make assumptions which could be technically possible or technologically possible. So the challenge is, if you want to find out exact problem, is resources are reserved here, resources are already reserved here. So in both the places the resources are reserved. The routing is the issue now. The packet is coming like this, right? I want to stop this flow at some point where the packet should come here, and when that happens, before that instant in time I should be here and left this. Right? So you will need some help from the mobile switching center. Right?
So, like, normally the mobile switching centers are synced to your phone, so the clocks are synced.
Right.
Time is synced, so
Yes.
they can based on the speed at which I'm
Yes.
currently moving, you can
Yes.
possibly decide that in this much amount of time,
Right.
I will be in the next, the area of the next PSS.
Yes.
So at that time, both of them can just
Right.
connect to the new.
Right. So you can use time is a good one way to do that. If we assume that everything is globally synced, and that's a fair assumption, then you can do that. Another thing is, even if the time is not properly synchronized, what you can do is the phone knows where it is, right? So at one instant it is in old base station with old BSS, that's fine. So it will tell, unless and until I receive a message from the cell phone that saying that I am in the new BSS, I will not forward that packet to the new BSS. Right? So at one instant you receive all these packets, and you can tell MSC, you stop, go here, you join it, and you say, okay, give me packets. Right? So there will be a little delay. So when you are talking on the phone call, there could be a slight pause or a gap when you are making the conversation, but that's fine, you haven't dropped anything, right? Or you haven't duplicated anything. So the call will be still clear after an instant, right? So with this, you will make sure that nothing is dropped and nothing is duplicated, and you will get all these new packets. So is the solution clear? So what I am saying is, you can actually get help from the MSC, and with that help, you can tell to stop for an instant, make a jump to the next cell phone tower, and then ask him to start the flow again, and you can get all the packets. And so with this, there is no duplication and there is no dropping of packets. So let me just say this. So old BSS inform MSC of impending. So BSS will coordinate with MSC and saying, okay, there is a handoff. Right? So this is what I was saying. So MSC also knows that there will be a handoff. MSC sets a path to the new BSS. So the path, even that routing path is allocated. New BSS allocates a radio channel. So this path is entirely established like this. Now the new BSS signal MSC and new BSS signal MSC old BSS that it is ready. So this BSS will tell, okay, that here also and here also I am ready now. So that ready message is saying that now you can stop this flow and start the flow here. Right? So all of these are coordinating with each other, all these three entities, to do the handoff. So old BSS tells mobile, perform the handoff now, because that path is already established, everything is in place, so you can actually go there. Mobile and new BSS signal to activate the new channel, and with using the new channel, the handoff is complete and the call is routed there. So all these three entities exchange messages, do the coordination, and then do the proper handoff. So it's a very complex system actually, because all these messages go and back, you don't realize it. But that's why when there could be this little pause, and then immediately you can hear the voice again. So this is how it is done within the same MSC. And within the same MSC, from one cell to another cell, this is how you make the handoff. So let's take a break of 5 minutes. To another cell within the same MSC. So, the next thing would be moving within. I'm still in the home network, but moving from one MSC to another MSC. So how this is done? So there is something called an anchor MSC. We are just following again the same principle of mobile anchor. So first MSC visited during the call. So once you switch on your phone, you will connect to one cell phone tower. Right? So let's say your phone is off. You switch it on. It will talk to the first tower, and then that will be your anchor MSC, the corresponding MSC, switching center. Right? So you are registered with that MSC. And all the calls and communication now will go through that. When you move to the new MSC add on to the end of MSC chain as the mobile moves from one MSC to another MSC. So what's happening is you are established. So this is your anchor MSC, your first MSC. Your call is here. You move from, so within this it's fine. When you move from one MSC to another MSC, this is a little complex handoff. It's not between one cell. So you have to involve one cell phone tower, second cell phone tower, and two different MSCs. So in the previous case, we had three entities: BSS1, BSS2, and MSC. And now what we have is MSC1, MSC2, and then there will be BSS1 and BSS2. Right? So this is how the connection is. So all four of this can do the handoff step. Right? So when you move from one, so this will be one cell and this will be another cell. You move from one cell to another cell, and all of them will coordinate to do the phone call. Right? So it's just that instead of three, now we have four entities and they can talk to each other and make sure that the call is not dropped or echoed or duplicated. Right? So the protocol will still be the same, but this MSC has to talk to each other. And then what you do is you form a chain. Because dynamically you don't want to break this connection and establish this issue. Because the call is already going on. Right? Somebody is talking to you from the landline. Right? So the landline call will always come to the home MSC, anchor MSC, and then, home MSC and then the anchor MSC and then here. And if you move from here to here, the call will be routed. Right? So if you are very fast, let's say you are in the metro, right, and you start the phone call at one station, after 20 stations you probably will switch MSCs. Right? And in that case, what is really happening is your phone call is actually going to one MSC, to second MSC, to third MSC, and fourth MSC. Right? So that's why mobility is a very hard thing for the cell phone operators. Because now this wire is busy, this wire is busy, this wire is busy, and this wire is busy. Right? So if you are very mobile, it's taxing for the cell phone operators. So if there are too many people in the metros, it's not good for the cell phone companies, because the call has to go through multiple MSCs like this. So that is how it is done. So this is also possible, but it's just that there will be a change. So we talked about, this is the last slide, we talked about mobility in this chapter. But the challenge was you could be mobile and moving from one location to another location very fast. But the simplicity was that you will still have something called home, and then you visit something. Right? So your home is always your permanent address, and you send packets through the home network to the visiting networks. Right? And this is the protocol, as you saw. It's same in IP and it's the same in GSM. Everywhere is the same. After your presentation will go into a complex system where you will still be mobile, but there is no home agent, there is no visiting network, there is no access point, everything is add-on, everything is peer-to-peer. Right? And you can now imagine, because there is no home network, there is no permanent address, how do you contact this other person? And that is where the protocols will come, and the protocols are called AODV and DSR. So these are the next level of protocols in mobility, where you don't even have a permanent address or a home network, and you can still be mobile.
So there's something like broadcast and
multicast. Right. So there will be little broadcast involved, multicast involved, and so it's like you have 10 laptops. Everybody is moving with the laptop, and you can still route the packets between. So every laptop is now a router. And we'll see those protocols. Those are little complex, as you imagine, but there is no permanent address, right? So those protocols are little complex. So what I would recommend, you refresh your knowledge of link state and what is it called? Distance vector. Right? So you know the standard protocol, distance vector routing and link state routing. So you refresh that knowledge, and on top of that we'll build these new protocols of mobility. So let's stop here today. So this chapter is over. So I have already posted the slides for the entire chapter. So you can go through the slides.